All right, so this is a continuation on 11.4, which is solving with logarithms. What you should notice right now is that there actually aren't any logs at all in these problems. Okay, but instead, when we look at it, the issue is we have an exponent here that it has a variable in it, and we're not allowed to have exponents that have variables in them if we're going to solve, because we need to get the variable out of the exponent so that then we can get that exponent alone. So, in order to deal with this, our first step should be to change from exponential to log form. Right? And the reason behind that is to get the variable out of the exponent. And we've done that before in previous lessons to get the variable out of the exponent as well. So remember that formula, if you forgot, remember if I have something like b to the x equals a, then it would be log base b of a equals x, right? The base of the answer equals the exponent. So when I look at this first problem here, that means log of the base would be 2, log base b, which is 2, of 5 equals x plus 3 for the exponent. And now that we've gotten that done, all we really need to do is to isolate the variable. So since I'm solving for x, that would mean subtracting 3. So we would have log base 2 of 5 minus 3 equals x. And now x is by itself. So your final answer is just log base 2 of 5 minus 3. Now don't try to put these together, right? We don't want to put it together with division because this one is a log. This one does not have a log attached to it. So this is just your final answer. And then you're going to go ahead and try number 2 on your own. All right. Number 4, or section 4, is all about solving logs with different bases. And by different bases, I really mean like ones that aren't base e or base 10, so not the common log and not the natural log. Okay, and remember from before when we were graphing logarithmic equations, if I gave you something like log base b of a, we could change that into log of a over log of b. And the way I like to remember that is, since b stands for base, because this is the base goes on the bottom, right? The base of the equation is at the bottom, so the log of the base goes on the bottom, and then the big number goes on top. So the a part. Right? So now we're not even going to worry about solving, we're really just going to evaluate these. So when I look at this one, I can't really I don't know 5 to what power would give me 16, so I'm going to have to change that to be log of 16 over log of 5, and then I really just need to go ahead and take out my calculator and go to my main screen and type it in. So log of 16, make sure you close your parentheses so that your calculator knows you're done with that log. Divide it by log of 5 and close my parenthesis again. And we end up with 1.723, okay, because that 7 will make that other 2 become a 3. So 1.723 as your final answer. And you can go ahead and try number 2 and try number 3 on your own. And then we'll go ahead and look at these application problems. So looking at number 1, if Paige deposits $16,000 into a bank account and it compounds annually. So remember, if it were continuously, it'd be A equals P e to the RT, but because it's compounded annually, that means we're using A equals P 1 plus R over N to the T power. And because it's annually, that means that's 1 time per year, right? Once per year. telling me that my n equals 1. So we need to decide what's my a, what's my p, what's my r, what's my n, what's my t, and we already know the n is 1. So Paige deposits $16,000. So that deposit is how much she's putting in initially, which is the principal, P. So that will be $16,000 into a bank account. It compounds annually at a rate of 7%. So my R is 0.07. How long will it take for her to have $20,000? So this is how much she wants. So that's the amount she wants in the end. So that's the A. And we don't know the T. So when I go to plug this in, it would be, my A is 20,000. 20,000 equals, then it would be 16,000 for my P. 1 plus R, which is 0.07, over N, which is 1. And then this is to the NT, right? So this would be 1 times T. And so this would end up just being a T here. So now I'd start simplifying. So 20,000 equals 16,000. Well, 0.07 divided by 1 would be 0.07. So 1 plus 0.07 is 1.07 to the T power. So now I have to start working to get that exponent alone. But remember, this number is attached to the exponent where the 16,000 isn't. So we're going to get rid of that 16,000 first by dividing by 16,000 on both sides, which would give me 1.25 equals 1.07 to the T. Now we can worry about getting this exponent out. So in order to get the T out of the exponent, we're going to have to change it to the log format. So log of the base, which in this case is 1.07, of the answer equals the exponent. So now my T is alone, so I would want to just have this as my answer, but because we now know how to do the change of base, we can get an actual number for this, and we need to get a number for the application because it doesn't make sense to say, oh, Paige will have $20,000 in log base 1.07 of 1.25 years. That wouldn't make any sense. So listen, we definitely have to type this in. So this would end up being T equals log of 1.25 divided by log of 1.07. So you can get out your calculator and type that in. So log of 1.25 divided by log of 1.07 would give me 3.298. But remember, this is a word problem, so you have to answer in a sentence. So I would say Paige will have, remember she's trying to get $20,000 after, I'll round that to 3.3 years. And it's important that you put the 20,000 because if it were a different amount of money, it would take a different amount of time. Now I want you to go ahead and try number 2 on your own, and we'll go over everything later.